Hello, welcome back. Here we are another day on the 6v6 amp. The mains transformer is just about finished and we'll start more work on the actual beastie today and get a lot done. If you don't like seeing dead animals, don't watch this next bit. Close your eyes or look away or something. So I found this one in my bedroom last night. I hadn't killed it, and it looked like something's had a pop at it. Another mouse probably. Yeah, I won't show you. Yeah, you can see it's like, yeah, not died in a happy state. And then I came down this morning and we managed to get one in the trap. I don't like killing animals, but when you've got mice in your house it's not good, because they do shit everywhere. I know up there behind all those things there'll be mouse crap, and of course they fucking get inside all your test equipment, pissing shit everywhere. It isn't funny, so yeah, don't like killing animals, but go outside next time. Right? Okie dokie. We're on the final run with this mains transformer. I got up to about 250 odd volts this morning. So we need about another 30 volts and we're done. Hurrah! So then, because I've been a good boy and put lots of turns on the said mains transformer. Did I say output transformer just then? Bit confused, I just had my booster. Yes, because I've been a good lad, I'm starting to put more controls bits onto the amplifier chassis. So we've got a couple of RCAs and I'm just about to put the volume pot on, and then that got me thinking about the balance pot. Blah 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 blah. So balance pot, not as straightforward as it looks. If we have like our volume pot first, 1 meg volume pot, and then we was to put like a balance pot there with a wiper to ground, so we've got a variable resistance here. So we've got the output from in the wiper in the 1 meg going into our whatever it is, let's say 100k, with wiper to ground. Then that is alternately sending, say, this channel more of the signal to ground or less of the signal to ground. I don't know if that works because we've got quite a variable. Say if this pot, for instance, pot B here, say if this section of the pot was grounded, anyway, for whatever reason I discounted that, and then I had to look at a few stereo amps online, and I think the way to do it is to have, we've got a 250k dual gang pot, then our 1 meg volume pot. So that works out at, right, say that our balance pot mostly is centered, so we've got 125 ohms, sorry, 125 kilo ohms, 125 kilo ohms in parallel with 1 meg. That equals 100k sort of source impedance going in, and that'd be a 250k impedance to our whatever we're plugging into it, yeah? So that's good. And then the only other thing I really need to do on the inputs before all that is to put an RF low pass filter. Normally in an amplifier we only employ sort of high pass filters, or that intentional high pass filters. So we usually have a cap, say in a resistor to ground, and then that said goes into a grid of a valve, say. So this is a high pass filter, meaning that it's letting in all frequencies over, well no, it's letting in all frequencies up to a certain point. Low pass filter is the opposite. It's starting off at only letting in signals over a certain frequency. So I've chosen a cut-off frequency of 100 kilohertz. That means 4K7 resistor with a 330 picofarad to ground. And that will stop any RF malarkey going in, because on our 2C34 amplifier I didn't do that, and with certain devices you could hear it going in, the RF was getting in. So basically all that means is just putting a little resistor and a cap just on the input there, and then that'll go to there and then to our right. That's a good point. Really it wants to go into our balance pot, ought to be here, and our volume pot wants to be over here. Regarding that, pots usually have like a little nib, like a locking nib, to stop it revolving round when you turn the knob. If you put one of these big spiky shake proof washers on the back, not the front, that will lock it in place, I find. Right, I think that's it. More later. One valve base in, nuts tightened. Another tip, with these RCA what do you call it, connectors, sometimes you have a right job, because these little ground earth connector thingies will spin round as you're trying to tighten them up. If you lock them into place first with a little bus bar between the two, then they won't spin round and you'll be able to tighten them up without them going all over the freaking shop. Ta-da! That's not looking too bad, is it? Yeah, I'm a bit happier now. Oh, it's got a bit of muck there, peanut. A few things obviously not right. Mucky knobs, I don't know if those knobs are right. Perhaps a little bit too big. But yeah, everything else, it detracts away from that bright blue colour, doesn't it? The blue on its own, whoa, but with all the bits and bobs, it's a bit better. So, onwards and upwards. We're finally getting towards the end of this, winding this transformer. See what we got. 270 volts. Hurrah! I've only got another 15 to go. However, right, can you see that? Fucking glare everywhere. 270. Bugger! 240. Oh well. So that's it with it loaded. With 3K, which is 81 milliamps. So we're losing what, 30 volts? Yeah, we're losing about 30 volts, 28 volts. So onwards and upwards anyway. I think another, if I finish going round to there, to the end there, we should be right. Turn that off before I go touching it. I've worked out basically each revolution, each layer is about 35 volts. So there we go. As I say, 10 turns is 2.6 volts. So yeah, you do the maths. Well, I've come to the end and gone past another revolution, and we're getting loaded. This is 250 volts. That gives us 353 volts DC, or you know, so we're short of about 35 volts because of that 70 volt voltage drop on the 1K resistor. Let me just check. Alright, we have the right voltage going in. Ah! Good job I checked on it, look. Hold on, what is going off? I know what's going off. I have got the lamp limiter in. Right. Okay, we could have been really. Right, it's about 242 volts. Right, now then, let's check. Sorry, look. Right, 242. There was a 210 going in because we had our lamp limiter engaged. Right, let's turn that off and then check it again. Aha! 288. That's better. So we needed 285. I was thinking, how can my calculations be that much out? I was really starting to get worried then that I'd have to put another layer on. Right, well that's over voltage. I might need to take some off in that case. Only about 10 turns. But that's good, that is. My calculations work. It's nice to be right sometimes, although it's also very easy to screw up and forget to do something. Because I could have just gone and put a whole new bloody layer of windings on there and then had to take them all off again. Wouldn't that have been jolly, eh? Right, well now I've done that, I'll get it right and then I'm going to start back on the chassis. Righty ho, onwards and upwards and all that. I've just been thinking we'll put the bus bar in there. Pin 6 on the 6v6 sockets aren't connected to anything, so we can use those to pop our ground bus bar in. And that means, right, number 8 is our cathode here. That one, so we can get a resistor over there. 8, a little bit more tricky there. We'll work it out, we'll figure it out as we go along. The only other thing is we've got to provide HT to the screen grids of the 6v6s and HT to the anodes of the 607. So we might either need to put a tag strip in, or more probably I'll use one of those standoffs that Robin gave me. That's probably the best solution there. So first I'm going to just do a little bit of working out and then we'll take it from there. Mind you, right, you see that's there, our what do you call it's going to be there, isn't it? Oh fuck a duck. I didn't think of that. Yeah, our mains transformer's going to be there. Right, so what are we going to do about that then? Right, might have to have a rethink there. Okie dokie. So, one thing I don't think I pointed out was we've got our RF filters in, low pass filters in. I think these are wrong. Yesterday when I was testing this, it was rolling off all the way to about 20 kilohertz. There was, you know, basically a attenuation of the signal at 20 kilohertz. No good. So I think we may need to lower the value of those resistors and make the cut-off point, as it were, higher than 100 kilohertz. So anyway, they're in. That goes to a balance pot. That works okay. And then that goes to a volume pot. Then from a volume pot, it's going to go to here. So we've got like a little ground bus over here, and that is grounded all the way through this green cable. And that ground is then going to come there to this sub bus. So this is the current flow. I think I've waffled on about it in other videos. To cut down hum, this is. We don't want So here's our main power supply, will be over here. That'll be our main sort of power supply ground. Everything has to come here. So the smaller signals, like input here, come first in the queue. And then we've got a humdinger next. And then we've got our two, well, it will be our two cathodes of our 6v6s, and they will all go to that one point there. So we've got heavy current, less current, we've got a bit of current from the AC humdinger, and then we've got finally very little here, a few milliamps. That's the plan. I might need to change it. So if I can get some cathode resistors in, and the 6v6 cathode resistors in, and other bits and bobs, the 606 SL7 cathode resistors in, and caps and what have you, then we'll be good. I do need to change those freaking RF filter. Well, it is RFI filter. I've got to change them. Like I say, they're rolling off far too low. They're still having attenuation at 20 kilohertz. Not good. Bit of progress. We've got some of the components in. Well, I think we've got all the components in for the 6 SL7. So we've got some 2K cathode resistors, the 470K grid resistors, and those 2K caps have got 47 microfarad decoupling caps across them. We've got the anode resistors in. That's going to a standoff there. That will be supplied with a HT, but it'll be decoupled, unlike the prototype. Blah blah blah. We've got the 6v6 cathode resistors in. We've got a bus bar in, and I think I mentioned that this morning. We've got all the inputs wiring in. We just need to wire from there to there now. We've got the power supply components in. So we've got the two 220 mic caps, a 1K drop-in RC filter resistor thingy, and we've got a 600 volt bridge rectifier. I would have preferred a 1000 volt bridge rectifier, but that's all I've got. Regarding the drop-in resistor, I wanted something bigger, but I've got nothing really suitable. I've got a 680R. That looks like a probably, God knows, 50 watt resistor, God knows, and a 1K5. That would have probably gone in there nice, but that would have meant putting some more turns probably on the mains transformer. Not good. So yeah, our AC from our transformer will go into our bridge rectifier, blah blah blah, into there. Then pardon me, we'll have a drop-in resistor going to this standoff here. That'll be decoupling for the screen grids for the two 6v6s, and then that will in turn will go over to here, this standoff here, for the 6 SL7 anodes. I think that's about it. I'm gonna have to knock it on the head for today, even though I'd like to go on. I've had to go into town earlier on to bloody Tesco's. Everybody's going mad. It's like insanity in there. It's like the shops are going to be shut for like the next 6 weeks or something. Everybody, the place was packed out. This was about 10 o'clock this morning. People are just chucking loads and loads of stuff in their shopping trolleys, and yeah, I had to force my way round. So yeah, my legs really took a bashing from that. Oh well, but I mean, you can't get a where do you call it? You can't get a delivery because of COVID and freaking Christmas. Bloody Christmas. Anyway, I digress. I shall get this uploaded and ready for you to see in the morning.